I just want to mention to you about a special limit, and that is the limit of 1 plus 1 over n to the power n. Now when you are computing these sort of limits, now let's say for example, if you take the limit of let's say 1 plus 1 over n, then to compute the limit of this one, we can directly plug in the infinity and see what will happen to this total term. So when you plug in infinity, this term will be 0, so you will end up with 1. And let's say if you have a limit something like this, you can see that when you plug in infinity, that means when you associate infinity with n, then this becomes very large, so the total result will be very large value. So it's very similar to directly plug in infinity for these numbers. But the thing is, that sort of a direct substitution is only possible when, when you have a power and a power and a base. That sort of a substitution is only possible when the other character is not depending on n. That is, you can do the substitution for the base if the power does not depend on n, and you can do the substitution for the power if the base does not depend on n. So for example, now see here, the power is 1, which does not depend on n, right? So you can substitute whatever the limit here in the base, and in here, since the base does not depend on n, you can directly substitute the value in the power. But see, in this case, you cannot do such a thing, right? That is, that comes with the limit laws, right? So a similar approach cannot be taken in order to evaluate the limit of this term. And mathematicians have have proved the limit of this term to be equal to e by a separate method, right? It's not a direct plug-in or direct substitution, but with a totally different approach, the mathematicians have proved that the limit of this term is equal to e. And in a more general setting, they have even proved that the limit of this thing, when n goes to infinity, limit of this one is equal to e to the power x. So this is a very important result as we take this as a sequence, right? So the limit of this sequence is equal to e to the power x. Now here you have n, right? So you have to remember this limit result, right? So here there are two important things. When you have this limit variable in the base as well as in the power, you cannot directly substitute this limit and obtain the answer. There should be some different approaches, and this is a situation where you have the n value in both base as well as in the power, and mathematicians have used some sort of a different approach to prove that the limit of this one is equal to e to the power x, and this is a byproduct of this equation. See here, if we substitute x equals 1, then you will eventually obtain this result, right? So it's better if you remember this equation.